Hello, my name is Keely Murphy, and today I'll be presenting the video demonstration of our 464 final project. As you know, our team created a remote control weather robot for exoplanet exploration, so I'll go ahead and give you a tour of all the components you have seen on the previous slides. So I'll start with the motor systems. There are 4 wheels, each are controlled by one motor, and the motors are separated into 2 separate circuits. So the front motors are on one circuit and the back motors are on another, and each motor pair is controlled by a separate L29 3D chip. You can see them through these wires. One's here and one is here. In order to power our 5-volt battery pack that powers the Arduino and the sensors was not enough to power the motors, so we had to wire in a 9-volt battery, as you can see on either side, into each motor system. The ultrasonic sensor in the front acts as an emergency stop, so it monitors for obstacles, and if the rover moves within 10 centimeters of an obstacle, it automatically stops and is only able to perform backing up movements in order to stop the driver, who would be stationed at the habitat far away from the rover, from accidentally driving it into, let's say, a rock, and it's stuck and you don't know, and also damaging the components. Our system receives inputs by this Roku remote, which sends IR signals to this IR receiver, which then translates the unique signals each button sends into different directions of movement. So up is forward, down is backwards, left and right are left and right turns, and OK is stop. I'll go ahead and demonstrate that now. Forward and stop, backwards and stop, left turn, stop, right turn, and stop. A little further because I want it to point towards here now. So I'm going to demonstrate the emergency stop function by driving it towards this basket. Just for sake of time, I'm going to move a little closer. And it should automatically stop when it hits 10 centimeters from that basket. So I'll go ahead and show you that I won't push the button to stop. As you see, it reach the basket, it won't, if I push the forward button, it won't drive forward anymore or do left and right turns. So it's registered that it is at an obstacle and will not drive itself into the obstacle. So while remote controlled driving and controls are important for any rover, the main purpose of this project was monitoring the weather conditions. So I'll go ahead and introduce you to the sensors we use to do that. So you may be very familiar with this one, the DHT11 temperature and humidity sensor, although we only use the humidity capability for this project because this other sensor, the BMP180, which measures temperature and pressure, measures both, and it needs the temperature calculation to get the pressure. So in order to reduce redundancy of calculating temperature twice, we only use this temperature instead of the DHT11s. So the system obtains humidity, temperature, and pressure and displays them in a data structure, and then that data structure is sent through this NRF LO1 radio transmitter, which transmits data from here to the receiver. This receiving radio is hooked up to another Arduino on a separate system. As you can see, these are separately powered, and it displays data in the serial port. So I'll go ahead and clear it and reset the systems for both Arduinos. And you can see that every few seconds it updates the new status of the humidity, pressure, and temperature. The only other feature of note here, as you can see, none of these are changing very much, but the only other feature of note is that if the driver were to encounter an obstacle, so let's say now it would be reading it as an obstacled state. It would not allow you to drive forward, turn right, or turn left, only drive backwards. It takes a minute for it to register and send back to the receiver, but it would say emergency stop, obstacle ahead on this serial monitor in order to alert the driver that, the vehicle is actually not moving and he's going to need to back up a little bit in order to figure out how to get around the obstacle.